আমরা আজকে ট্রি সিরিজের লেকচার 5 শুরু করতে যাচ্ছি এবং এই লেকচারে আমরা দেখব কিভাবে আমরা একটা বাইনারি ট্রির উপর ট্রাভার্স করব। Traversal means capturing all the nodes of a tree. From the previous lectures, we already know that a tree is a non-linear data structure. As a result, moving in a linear way doesn't capture all the nodes. Therefore, we don't have any option but move in a recursive manner. এবং traverse করার জন্য we have strictly three ways called pre-order, post-order, and in-order. আমরা আগে in-orderটা দেখি। So in-order traversal হচ্ছে we have a function and inside the function we do these three things. একটা হচ্ছে প্রথম কাজ হচ্ছে move to the left subtree recursively, which means moving to the left subtree is nothing but a recursive function call. Then we do the work and then again move to the right recursively, which means again a function call. Moving to the left subtree recursively means if we start from a node, let's say the root, আমরা যদি যে কোনো একটা নোড থেকে যদি শুরু করি, let's say root, আমরা বাম দিকে যেতেই থাকবো যে পর্যন্ত না আমার শেষে না পৌঁছায়। শেষ কিভাবে বুঝবো? যে নোডের বাম দিকে none আছে, let's like D, the left subtree or the left node of D is none. So this is where I stop. এটা মানে হচ্ছে এই প্রথম লাইনটা সেটা হচ্ছে মুভ টু দ্য লেফট সাবট্রি রিকার্সিভলি। আমরা শুধু একটা লেফট চাইল্ডে গিয়ে থেমে থাকবো না, উই উইল বি কিপ অন মুভিং টু দ্য লেফট। যখন আমরা ডি তে পৌঁছাবো তখন দেখবো যে আমার লেফটে আর কোনো সাব ট্রি নাই, তখন মানে হচ্ছে তখন ডি এর ক্ষেত্রে প্রথম লাইনটার কাজ শেষ হবে। প্রথম লাইন কাজ শেষ হওয়ার পর আমরা দ্বিতীয় লাইনে চলে যাব। দ্বিতীয় লাইন মানে হচ্ছে we will do the actual work on a node. And the actual work could be anything, but the simplest of all work is just to print. So we started from A, we moved to the left recursively, which means we kept on moving to the left until we reached D, and then we will print the element of D. After printing, we will move to the right recursively. তার মানে হচ্ছে again from D we will be moving to the right. Okay, recursively মানে হচ্ছে we will be keeping on moving to the right until we reach none. So আমরা recursion এর ব্যাপারে already জানি যে every recursion call is saved in a stack. So whenever we make a recursive call, we move to a new state. তো এই ফাংশনটা যদি আমরা আরেকটু সুন্দর করে লিখি তাহলে জিনিসটা এমন দাঁড়াবে। So we have a function where we have a node n. So from n we will move to the left, which is n dot left, এবং শুধু n dot left এ যে থামবো না, we have to keep on moving. So we recursively call function and n dot left. Then after যখন আমরা দেখবো যে n dot left এ কিছু নাই, so let's put a condition before the function call. Let's say if n dot left not equals none, we keep on moving left. And at the point when n dot left becomes none, for example, যখন আমি d তে এসে পড়ি, আমরা দেখি যে d এর লেফটে none আছে, তখন কি করব? তখন রিয়েল ওয়ার্কটা করব। এই ক্ষেত্রে let's say the real work is print. So say print. and then we do a check again. If n dot right not equals none, so we recursively call the function on n dot right. And if n dot right is none, for example, when we are at d, d's right is also none, তখন এটার পরে আর কিছু কোনো কাজ হবে না। And as this is a void function, we know that at the end we have something called a return. তার মানে হচ্ছে when this line gets executed, the state function state will be popped from the stack and will be backtracking to the previous stage, to the previous state. ঠিক আছে? তো আমরা একটু ট্রেস করি, তাহলে আমরা আরো ক্লিয়ারলি বুঝতে পারবো। Let's erase this part completely. And let's trace. So we start from A. So এটা আমাদের প্রথম স্টেট, যেখানে আমি ফাংশন কলটা প্রথমবার কল করলাম এবং আমার ইনিশিয়াল n হচ্ছে A নোডটা A. So let's say A. তো এখানে আমি কি দেখলাম, কি চেক করব, if n dot left not equals none, A এর left কি none from the diagram? No. Then I call the function again. So এখানে আমি আবার ফাংশনটা কল করলাম on A dot left, which is this particular node B. So এইখান থেকে আমার একটা ফাংশন কল হচ্ছে, this is my second state where I'm calling the same function on B, and I'll do the run the exact same lines. First কি চেক করব, B এর left none কিনা, B এর left none নাই, তাহলে আমি কি করতে যাচ্ছি, আবার ফাংশন কল on B dot left, which is D. So I'm calling the same function on D. So এখান থেকে আমার নতুন একটা ফাংশন কল হচ্ছে on D. এখন চেক করব if D is left none কিনা, yes D is left is none, so আমি if এ যাব না, if এ যাব না মানে হচ্ছে তাহলে ফাংশন কলটা হবে না, তাহলে আমি প্রিন্টে চলে আসলাম, প্রিন্ট লেখা আছে n dot element, তার মানে হচ্ছে D প্রিন্ট হবে, so my output, the first output is D. So for D আমার if এ গেলাম না, প্রিন্ট করলাম, আবার একটা if কন্ডিশন এখন চেক করবো যে if n dot right not equals none, no D right is also none, তো D এর জন্য এই পার্টিকুলার স্টেটের জন্য আমি এই if কন্ডিশনটাও ট্রু হলো না, তার মানে হচ্ছে I'm done executing all the lines, I'm done executing if, যেটাতে false হলো for D, প্রিন্ট করলাম, এই ifটা false হয়ে গেল, তাহলে ফাইনালি কি রিটার্ন কি বাকি থাকে, রিটার্ন, তার মানে হচ্ছে এই স্টেটটা পুরো শেষ হয়ে গেল এবং আমি পূর্বের স্টেটে রিটার্ন করে ফেললাম। পূর্বের স্টেটে আমার কতটুকু কাজ হয়েছিল আর কতটুকু বাকি ছিল, তো for B this if condition was executed, তো সেকেন্ড কি লাইন এক্সিকিউট হবে, these two lines or these two segments were remaining to be executed, এগুলো বাকি ছিল, তো এটা শেষ হওয়ার পর আমার এই সেগমেন্টটা কাজ হবে, সেটা হচ্ছে প্রিন্ট, so B will be printed, এই কাজটাও শেষ, তারপরে নেক্সট কাজটা কি করব, if n dot right not equals none, so from this state is B's right not equals none, yes B's right is not equals none, মানে if condition true হলো, তাহলে আমি কই যাব, ফাংশন কল করব on n dot right, so this part gets executed, which means a function call on the right, which is E. তো এইখান থেকে আমার একটা নতুন ফাংশন কল আসলো এবং আমি প্যারামিটারে পাঠাচ্ছি। এখন আবার এই সেম লাইনগুলো চেক হবে। সো ফার্স্টে চেক হবে n, which is left none কিনা, is none, তাহলে আমি if এ যাব না। পরের সেগমেন্টে কাজ হবে সেটা হলো print, will be printed, and then এই সেগমেন্টটা পর থার্ড ইফ, আই মিন সেকেন্ড ইফটা চেক হবে। সেকেন্ড ইফটাও untrue, so all these segments have been executed for তার মানে হচ্ছে it gets popped, and then we go back to the previous step or previous state where we were at B. এখন B র তিনটা কাজই শেষ, right? So B also gets popped and go to the previous state where we were working with A. আমরা A নিয়ে যখন কাজ করতেছিলাম তখন আমাদের, let's use a different ink color for A. So when we were working with A, this segment was executed. Then the second segment to be executed is print. So A will be printed. And then the third segment was remaining, which is if A's right is not none, then I will move to the right. So A's right is not none, so we will move to C. তো এই পার্টটা এক্সিকিউট হয়ে গেল এবং সাথে সাথে আমার আবার একটা ফাংশন কল হলো, মানে এইখান থেকে আমার আরেকটা ফাংশন কল হলো এবং নতুন একটা স্টেটে গেলাম এবং সি ফাংশনটা কল হচ্ছে সি এর উপর, so the function is called on C. And then let's use a different color, let's say green. Use green, let's say blue. Then on C, run the same lines again. Do the same thing as its recursion. So we will check if n's left is not none. So C's left is not none, so we'll move to F. F has no child in its left, no child in its right, so only F will be printed and go back. Then I'll be printing C, and then I'll be going to G. G has no left, so I'll be printing G. So after A, I'll be printing F, because after A, I'll be moving to C. C has a left child, so I'll be moving to F. F has no left, so F will be printed. F has no right, so I will backtrack to C. After backtracking, we will print C, and then we will move right. G has no left, then we will print G. G has no right, then we will go back to C. We are done with all the operations of C and then go back to A. We were done with everything on A, and therefore we are completely done. So this was the very first state where n was equal to A, and when all these lines were executed for A, this would be popped out, which means an empty stack, and when the stack is empty, we know that the entire function or the entire recursion is completed. And this is the output we get. So it might get it might be a little overwhelming because we've already seen that, and we already know that as a tree data structure gets, as a tree gets longer, things at every level, the number of nodes increases. Therefore, there are more function calls at every level. And we already know from recursion that if the recursion or the work we want to do works correctly for this smallest portion, it is guaranteed that it will work correctly for the rest of the tree, no matter how long the tree is. So while working, we just have to make sure that for this portion, it works fine. We do not have to worry about the rest of the tree. এখন এই in order traversalটা আরেকটু সিম্পল ভাবে দেখি। এখন যেটা দেখলাম সেটা হচ্ছে very much very much how it works inside. Okay. But now let's take a high level view of what's happening, and তাহলে এটা আরো ক্লিয়ার হয়ে যাবে। So let's use the same tree. So let's say, so in order traversal, let's say a high level overview. So we know that in order means move to the left, work, move to the right. And left and right are recursive. So as we are beginners, there's a trick to get this thing really easy. Let's say left is L, work is S, self, and right is R. Now let us write LSR beside every node. Now let us start from L. Let us start from the root. So when I look at the root, it says that we have to move to the left first. Use a different ink color. So I'm at the root and it says I have to move to the left first. So I move to the left from A, and when I move to the left, I cancel L out. It means I am done with L. So I move to the left. When I move to B, I see that L is remaining. So I move to the left and I cancel L. So moving to the left from B is D. So from D, I see that L is remaining. So I move to the left of D and I cancel out L. So as D has no left child, it means that I don't have anywhere to go. Therefore, the second job is S. S is basically print. So I print D and cancel it out because I'm done with printing. And then remaining is R. So we move to the right, but there's nothing on the right, so we cancel it out. So when these three operations are done, it means popping out of the stack. So we backtrack to where we came from. So we came to D from B, so we backtrack to B. So when I backtrack to B, I see that S, which is print, is remaining. I'm done with L, and sequentially, as we are moving sequentially, L is done. So the second work to be done is print. So we print B, cancel this S, and the remaining job is to move to the right. So we move to the right of B, and we cancel R. So when we move from B to E, we see that the remaining is L. So we move to the left of E, but it doesn't have any left subtree. So you simply cancel R but and do nothing. And then you see that the next operation is S, which is print. So you print E, cancel this out. And the next operation is R. There's nothing on the right. So you cancel R and you backtrack to where you came from. So when I backtrack to B, I see that all of these operations are completed, which means I have to backtrack to where I came from, and that is A. When I backtrack to A, I see that S is remaining, which is printing the element, printing A. Cancel this out, and I have to move to the right. So I move to the right of A and cancel this out. Now I'm at C. I see that L is remaining. So I move to the left of C, cancel it out. I'm at F. I see that left is remaining. So I move to the left, but there's nothing. So I move to the left, but I see that there's nothing. So I'm at F. I, I see that S is remaining, which is print. So I cancel it out and I print F. And I move to the right, but there's nothing on the right. Therefore, all these have been completed and I backtrack to C. When I backtrack to C, I see that printing is remaining. So I print C, cancel this out because I've already done printing. And then I see that R is remaining, so I move to the right. And as I move to the right, I cancel it out. I'm at G now. I move to the left, but there is nowhere to go. I print G, and then I move to the right. There's nothing to go. As LSR is completed, I go back to where I came from. I go back to C. When I'm at C, I see that LSR is also completed for C, so I go back to A, and I also see that LSR is completed for A, and that's it, I'm done. So this is the in order traversal output of this particular tree. So in means in between. Okay, so we are doing the real work in between moving to the left and moving to the right. When we say pre-order, pre means before. This means we print or do the work before we move to the left and then we move to the right. And these two are again recursive calls. Therefore, if I have to do a pre-order on the same tree, so pre-order means work, left, right, so we call it SLR, self, move to the left and move to the right. So we do the exact same thing. We write SLR on every node or beside every node. And do the exact same thing. So we start from the root. The first job is self, so I print A first, then I cancel it out, then I move to the left. I move to B. As I have moved to B, this work is also done, so cancel L. Now I'm at B, I see that S is remaining, so I print B, or I do the work, which is printing. Then I move to the left, I move to D. So after moving, L is done. So I'm at D, I print D because it says to print. Then I move to left, I move to the left, but there's nothing. I'm done moving to the left. Then I move to the right. There's nothing on the right. I'm also done. So SLR done for D, so we backtrack to B. When we move to B, we see that S and L are done. So the only job is remaining is to move to the right. So we move to the right. So after we reach E, we also cancel this out. For E, we have to first print, then move left. There's nothing on the left. Move right, nothing on the right. SLR done. We go back to where we came from, and that's B. SLR done for B as well. So we go back to A. For A, R is remaining, so we move to the right, cancel R. For C, SLR all remaining, so we stop printing. Then we move to the left. For F, printing is remaining, so we print F first. Move to the left, move to the right, SLR done, go back. R is remaining, so I move to R, print G, move left of G, move left of R, go back to C, SLR done for C, go back to A, SLR done for A, I'm done. My pre-order traversal is completed. And finally, we have something called post order, which is after moving to the left and after moving to the right. So post order means we first move to the left, then we move to the right, and then we do the work. So for the same tree, We write LSR beside every node, and then we work accordingly, starting from the root. We move to the left. From B, we move to the left. From D, we move to the left, but there's nothing, so we come back. We see S is there. We print D. Then we move to the right. LSR done. Go back. The remaining task is to print. So you print B. Move to the right. Over here, you first move to the left. Then you print E. Then you move to the right. LSR done. Go back. For B, LSR done. Go back. L was done for A. S was remaining, so you print A. Then you move to the right. For C, you move to the left first. For F, you move to the left. You print F. You move to the right. LSR done. Go back to C. Print C. Move right. For G, move left. Print G. Move right. SLR done for G. Go back. SLR done for C. Go back. I'm sorry. LSR done for C. Go back. LSR done for A. I'm done. So this is the post order traversal for this tree or any binary tree given. You just have to remember that in order means the work you have to do is in between moving to the left and right. Pre-order means you do the work before you move to the left and right. And post-order means after you move to left and right. And moving to the left and right is recursive. So which means we keep on moving to the left, we keep on moving to the right, and then we do the work. And we are already familiar with recursion and with the backtracking thing. I don't think this will be a problem. So, uh, so if you want to understand how traversal works, this high level uh, overview, like this high level is good enough, but you must know what really happens inside. Okay, that's it in this lecture. Thank you.